Hello, algebra students. Today's another great day of flexible learning. Let's keep talking about exponent rules. Today we're going to talk about negative exponents, exponents that are equal to 0, and what happens when you have a fraction as your exponent. Let's start. So here's an example. I've got 5 to the 4th over 5 to the 6th. You might recognize this from my last video, but it was 5 to the 6th over 5 to the 4th, so I've now reversed this. So we're going to use that same rule that we learned in the last video, and let's see what happens. So according to my quotient of power rule, that's this one over here, I should be subtracting 4 minus 6, which would then simplify this to 5 to the negative 2. But it's a negative. What does that even mean? What does it mean to do 5 to the negative 2? Let's break this apart like we did in the last video. So I've already gone ahead and done that. The numerator is 5 times 5 times 5 because that 4 up here tells me to multiply 5 4 times. And the denominator, I've went ahead and written out 5 to the 6th. If you go ahead and I'm going to make these giant ones, there's the giant ones. Notice what happened. Was I left with any 5s in the numerator? No. And what happens when I'm left with nothing else in the numerator or denominator? Yeah, it's really just like having a 1 there. Because remember, all these 5s, they cancel out. Since they all become 1, they cancel out. And I don't have to write them again. Now this time, what am I left with in the denominator? Yeah, I'm left with 2 5s. So I'm really left with, go back to black, 1 over 5 squared. Now remember, when we did the quotient of power rule, we had 5 to the 4 minus 6 equaled 5 to the negative 2. So based off of what I found out here when I expanded it out, and what I found out here when I used the quotient of power rule, what do you think that negative exponent means? That's right. The negative exponent tells me that I need to move this entire thing down into the denominator. And we want to do that because it's not really nice to work with these negative exponents. So anytime you get a negative exponent, you have to move it down into the denominator or on the other side of the fraction bar. I'll talk about that more in a bit. So the final answer to this really is 1 over 5 squared. Let's try some more. So here's the negative power property. You can write this down. It's really nice to have in the corner of your paper when you're working on these problems. All right, here's 3 examples. In my first example, I've got x to the negative 7th. Again, I don't want to have negative exponents, so this really just simplifies to 1 over x to the 7th. These two things are the same. All right, so you want to flip that over the fraction line. If there's nothing else on top, it's a 1. In the second example, I've got y to the negative 3 and I've got z squared. Well, since the z is not a negative, I don't need to move that down into the denominator. But the y to the negative 3rd, that needs to get moved down to the denominator. So z squared stays in the numerator and y to the negative 3rd now moves to the denominator and the exponent becomes positive. Let's check out number 3 here. Number 3 is 1 over b to the negative 2. Now I said whenever you have a negative exponent, you move it down into the denominator. But what if there's a negative exponent in the denominator? Well, as I said before, you flip it over the fraction line. So if it's in the denominator, it's going to go to the numerator. If it's in the numerator, it's going to the denominator. So in order to get rid of the negative exponent here, I need to move this to the numerator. So this becomes b squared over 1, which really is just b squared. Let's check out this example. Again, quotient of powers tells me that I should be subtracting these two exponents. So I should be going x to the 2 minus 2. But that leaves me with x to the 0. What does that mean? Well, really quickly, if you notice, if we were to have expanded x squared over x squared out, you would have had x times x over x times x, creating two giant 1s with nothing left in the numerator or denominator. So really, this is equal to 1. And anytime you have x to the 0 power, it's equal to 1. This is called the 0 power property. And I'll recap that at the end of this video. Next, I just want to quickly talk about what it means when you have x to the 1/2. It's just another way of saying, hey, what's the square root of x? All right, so that 1/2 is really just telling me to make a radical. All right, what is the square root of x? So for example, let's try this one together. 9 to the 1/2. What would 9 to the 1/2 power be? Well, again, that 1/2 is telling me to write a square root. So it wants me to tell it, what is the square root of 9? That would be 3. So to recap this video, here's the rules we talked about. We talked about the negative power property, which was when we have x to the negative power, we've got a negative exponent, we're going to flip it over that fraction bar. Right? It's going to move down into the denominator. Or if it's in the denominator, it moves to the numerator. The next one we talked about was the 0 power property. Anytime you get x to the 0 or some number to the 0 power, it's always going to be equal to 1. That includes if I have, say, 9 to the 0 power. That's 1. 2 to the 0 power. That's 1. Anything to the 0 power is equal to 1. The last one we talked about it really quickly. We're not going to do too much with it this year, but fractional exponents. And anytime you have x to the 1/2 or some number to the 1/2, it's really just asking you, what's the square root of that number or variable? Reach out to your teachers if you have any questions on today's lesson. Good luck today.